Hello, in this video I'm going to do section B of the 2007 PAT. So I did section A in the previous video. This has got some mid-length questions that I'll run through here. We've got question 10 is a pilot plans to fly his aeroplane from his base to another airport 300 kilometers due north. He can travel at 170 kilometers per hour relative to the air. Sets off at 9 a.m. Aims his aeroplane due north. Calculate estimated arriving time assuming there's no wind. Right, so it's going to take him 300 over 170 hours in order to do it. So that is 1 hour and 13 over 17. So 13 over 17 times 60 is going to give us the number of minutes. So fortunately, we can use the calculator in the physics part of this paper. So that gives 46 minutes on top of the hour, so it's going to turn into 10:46 a.m. After flying for 1 hour, he discovers he's only 153 kilometers away, travelled along a line of bearing 10 degrees. Assuming the wind has been steady throughout the journey, calculate its speed. Right, so he thought he was doing that after an hour. He thought he was doing 170 kilometers. He's actually done 153 at an angle of 10 degrees. So that's our resultant. So the wind must have been at a vector, which is going to mean that we're adding up these two vectors to get the resultant. We say that's V. We've now got a triangle, which we've got two sides around an angle. So that's going to be cosine rule. V squared is 170 squared plus 153 squared minus 2 times 170 times 153 times cosine of 10 degrees. So that's giving me quite a lot to type into the calculator. But otherwise, this isn't too bad a question. It just means a lot of typing in, which I'm sort of filling for time with as I'm typing it in at the moment. And then, that's a high number. Oh, I haven't square rooted. I was going to say that's a high number. So yeah, square rooting that comes out at 32.9 kilometers per hour. Right, that's good. Question 11. Make a sketch of the diagram below. Indicate clearly the position and nature of the image formed by the mirror. All right, so we've got a mirror and we're looking at the mirror. The object's bouncing off it. Draw rays corresponding to light coming from the open circle. Mark any relevant angles. I'm going to try and draw some straight lines. So that'll come down and it will bounce up to the eye. So we need the angle of incidence to equal the angle of reflection. So I equals R on this, and we're going to get our image, which is going to be down here. So that's going to give us the location of the dot. This is going to be at the same level, and then you're going to have the image upside down. So yeah, that's a really straightforward question. I suppose there's only 3 marks, but yeah, not much to do there. Question 12. Oh, this looks like the simultaneous equation ones I used to put in all the time. These are really boring. Planet Pluto, radius of that, populated by 3 species of purple caterpillar. Yeah, of course it is. Studies have established the following facts. So, A line of 5 mauve caterpillars is as long as a line of 7 violet ones. Okay, 3 lavender and 1 mauve, same as 8 violet. Right, wonderful. And a line of 5 lavenders, 5 mauve and 2 violet. 5 lavender, 5 mauve, 2 violet is equal to 1 meter. Lavender caterpillar takes 10 seconds to crawl the length of a violet one. So the velocity of a lavender, I'm reusing V's, that's annoying. But yeah, we'll just make sure these one with subscripts, these are the velocities. That one's the length of a violet. Anyway, I forgot what this was. That length of a violet divided by 10. And that's that. So violet and mauve caterpillars both crawl twice as fast as lavender. So violet, velocity of violet is velocity of mauve, which is twice the velocity of the lavender. So we need how long it would take for a mauve caterpillar to crawl around the equator. Right, well, we'll come back to that bit. We have to solve these things over here. to get what they all are. M looks like a good one to maybe drop. So let's multiply the middle one by 5, and then everything's got 5m in it. So 15L plus 5m equals 40V. So now let's eliminate our m's. So we've got 15L plus 7V equals, yeah, still 43. I was getting ahead of myself for taking the 7 off. So 15L is 33V. And then in the bottom one, we've got 5L plus 9V is 1. So multiply all of that by 3 and then substitute in the 33V. So we're going to have 27, so 60V will be equal to 3. So V is equal to 5 centimeters. So what do we have to do now to get, so L we need to divide by 15 and multiply by 33. So that is going to be 11 centimeters. And then M is going to be 37 centimeters, 35 divided by 7. So that's good. So we've got those lengths. So what does this now mean? So our velocity of the lavender one is now, it's doing 0.5 centimeter a second. Well, 0.5, but that would be times 10 to the minus 2 meters per second. That's VL. The velocity of a mauve caterpillar is double that, so it's doing 1 centimeter per second. Okay, so VM equals 10 to the minus 2 meters per second. We need the equator of Pluto, so that is going to be 2 times pi times our radius, so times 1180 times 10 to the 3, seeing as we're all in meters, and we need to divide that by 10 to the 2. So our time is going to be equal to, so let's double that and say 2.36 times pi times, how many tens have we got? I've just nicked 3 from here. That'll be 6, and then that'll be 8 all in all. So yeah, and now we can just put that into the calculator, which is going to give to, yeah, trying to think, let's go to significant figures. I mean, they've given us 3 here, but 7.4 times 10 to the 8 seconds. Right, that's just fiddly rather than anything else. All right, question 13. We got the current in amperes through a certain type of non-linear resistor is given by this relationship, where V is a potential difference in volts across the resistor. Okay, this resistor connected in series to a fixed resistor. So we've got resistor, I don't know what the symbol is for a non-linear one. I'm just going to put variable because I don't know what else to call it. So they're in series, and a constant voltage source of 9 volts is connected across the series. Okay, so we've got 9 volt going on there. What value of resistance should the fixed resistor have? So we need to know what that, in order to get a current of 0.4 amps. Okay, I'll draw my arrow the wrong way around. Conventional current and all that. So we need to say 0.4 is going to be equal to 0.05 times V cubed, sorry, where V is the voltage across the non-linear resistor. So that is 4, and that's that. So how many halves go into 4 is 8. So V is going to be equal to 2 because we have to cube root it. So we've got 2 across here, so we must have 7 across there. So we need that, well, V equals I times R, 7 equals 0.4 times R. So we've got 70 over 4, 70 over 4, so that's 35 divided by 2, 17.5, 17.5 ohms. So again, not a bad one at all. Let's see what else they've got to offer. Oh, that's the end of the section. Right, so it's just those 4 questions. Yeah, they were fiddly more than anything else, but really not that too bad. Not bad at all. So I'll then move on to the long question in the next video as usual.